going to take a look at trigonometric ratios today and some applications that they have. To start with, we know sine is the opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent, and we're going to use the TI-30 multi-view display calculator to help us with our calculations. All right, to start with, riding down the road one day, I'm looking on the road trip, the sign that says we have a 6% grade for the next 2 miles. And as I'm driving down the hill a little bit further, I see these signs here where there's this runaway truck ramp where if a semi's brakes are failing or maybe burning out because of overuse, the semi can run up this ramp to slow down instead of continuing to go down this hill at a high rate of speed. And as I thought about that, I thought, man, that must be a really steep hill. So I wanted to figure out exactly how steep was it. Well, a 6% grade is talking about the slope. So on number 1 here, it says, what's the angle measure the road makes with the horizontal that has a 6% grade? All right, well, 6% grade. We know that a percentage is out of 100. So 6% grade means that this is 6 out of 100. Or this has a slope reduced down to 3 over 50. And we've learned that that the tangent, to find the angle measure that this makes with the horizontal, that the tangent ratio is opposite over adjacent, but we also know that the tangent ratio, or the tangent of theta, is equal to slope, which in this case is 3 over 50. All right, so that basically means we've got a rise here of 3, a run of 50, and let's take a look. To solve this, I would take my inverse. So the theta is going to equal the tangent inverse of 3/50. And then we go to our calculator to figure out exactly what the degree measure this angle is here that we're calculating theta, that line's going to make, or that road is making with the horizontal. So to do this, we go ahead, we get our second tangent of 3/50. And when we calculate that, we end up finding out, whoa, this is a very steep 3.4. Yes, you heard that right. 3.4 degree angle. Wow, that doesn't sound like much at all. 3.4 degrees, let's put this in perspective. If that's a 3.4 degree angle, let's pull out our protractor and take a look at what that actually is saying. 3.4 degrees, if I put my protractor on here and I measure an angle that is 3.4 degrees, I'm going to be somewhere, that's actually 4 degrees. I can't get a decimal, bump back up to 5 on me there. So it's going to be right in there. So that angle measure of 3.4 degrees means that this line, that road would be on, would be that red line right there. Well, hold on here. This road sign, if I look at that picture, that appears to be a really steep slope in comparison to a minor 3 degree angle that we have there. So let's take a look. What is that? If I bring this down here and figure out what that angle measure is, once again, using my protractor. Let's see what angle this guy makes with the horizontal. So we're going to put our protractor on, measure our angle. This angle measure is looking to be about 28 degrees, 27, 28 degrees. All right, so 28 degree angle is what we're making here with that. So the question is, what percentage grade would that come up to be? Okay, so go in the reverse direction. So this is a 28 degree angle that roadside is showing that the steep grade is that they're about to travel on going down that road. Well, to find this, I know that the tangent, once again, is the ratio to use because it's opposite over adjacent. And when we're talking about a percentage, remember it is out of 100. So it's going to be the tangent of my 28 degree angle is equal to my percentage, which last time happened to be 6, over 100, because we know percentage is always out of 100. So the rise is this percent that I'm trying to find over the run of 100. So the question is, what's the percentage going to be? Well, to solve this, we can simply write it as a proportion, and my percentage times 1 would just be percent, if I'm using that as my variable, would equal 100 times my tangent of 28. So I go back to my calculator here to figure out this road sign, how much of a lie this was. Appears that picture is a little bit biased, or a little bit deceiving, I guess I should say, as to how steep that road actually is. So let's take a look. I take the 100 times the tangent of 28, and I get an angle measure, or I shouldn't say an angle measure, but a percent grade that is 53%. All right, so what is the percent grade of the hill of the actual road sign? Well, this percent grade that this guy is on right here is actually, no, not 6%, but 53% grade. So the sign not necessarily real accurate, but amazingly enough, even though the road itself only had this real small 3.4% grade, it is still going to be very steep for a truck to go on for over a course of 2 miles. Matter of fact, cross-country runners probably would not want to run up that hill because that would be a long, winding grade to run up and would be very tiring. So anyway, some applications using our tangent ratio there. Let's take a look at one more. I can remember one summer I was working with my wife's uncle, and he was building a garage similar to what you see in the picture here. And we were working on putting the rafters up, like you can see that they're working here on this particular garage. And he had a blueprint, and his question for me was, what was the length that the rafter needed to be from the bird mouth cut to the ridge board with a horizontal length of 12.5 feet and an angle of elevation of 33 degrees. So let's try and make some understanding about what he was actually asking here. He needed to know this length from here, the ridge board, down to here, which is what's called the bird mouth cut, which on this diagram here is another cross cut of that. It's showing this length of the rafter. How long does that have to be from the bird mouth cut? And why is it called a bird mouth cut? Because right here on that rafter, you've got to cut out this portion right there inside of that board so it will fit on top of the wallboard. So this right here needed to be cut out of this board. Okay, so that's that bird mouth. So that rafter is going to sit smoothly on the top of the wall. So the question was, how long did it have to be from the ridge board down to this bird mouth cut? And what he had for information to share with me is he knew that the angle that we needed right here, this angle was going to be 33 degrees. So this angle, likewise in this diagram, the same thing, is got to be 33 degrees. So I'm going to draw this in. Maybe. Yep, there we go. From there to there, that's a 33-degree angle. And we knew that that length was right on at 12.5 feet. But the thing that the blueprint didn't show us was the length of this black line that I have drawn here, which represents the length of the rafter. So let's take a look, filling everything in that we know. We know that this horizontal length is 12.5 feet. We also know that this angle right here is 33 degrees. And the question he was asking me was, what length do we need to cut from the top of the rafter down to where we need to do that bird mouth cut? And we called that X. So as I look at this, I'm saying, well, this is my angle that I'm looking at is 33. In this right triangle here that's formed, I have an adjacent leg, and I need the hypotenuse. Well, adjacent and hypotenuse, that would be our cosine. So we would set this up as the cosine of 33. And that's going to be equal to the adjacent of 12.5 over the hypotenuse that I don't know. And as you do your solving here, you'd take x times the cosine of 33. And that would be equal to the 12.5. We'd have to solve for x. The opposite of multiplying by the cosine of 33 is going to be to divide. So we're going to divide each side by our cosine of 33. And when I divide by the cosine of 33, those guys are going to cancel out. And x ends up equaling what I get here when I take 12.5 and divide by the cosine of 33. We find out that it's 14 and change, so 14.9 feet. Now that didn't really help us on our tape measure, so what we had to do is a little conversion into inches. So I subtracted away the full unit of the 14 feet and realized we had 0.9 of a foot left. Well, 0.9, if we're converting to inches, we know there's 12 inches in a foot. So I take that 0.9 times 12, and that tells me it's actually 14 feet and 10 inches. And not only that, but the ruler or the tape measure is divided into 16ths. So if I subtract away the full unit of 10 inches, what's remaining is 0.85 of an inch. And since it's divided into 16ths, I can multiply that by 16 to get the fractional part on my tape measure. And we found out that it was about 13, rounds up to 14 sixteenths. 14 sixteenths, which reduces to 7/8. So we needed to cut that rafter at 14 feet, 10 7/8 inches in length from the bird mouth up to the rafter. Guys, there's all kinds of applications that go on here. This is just a practical example of something I did in building a garage. The previous one was honestly just some curiosity of me riding down the road, wondering exactly how steep that road was. You'd even find that in a plane, if any of you have ridden in a plane before, when the pilot starts to land, you can feel a definite descent. But the angle of the decline that he's going at is really only about 3, maybe 4 degrees at most. So not very steep, but it seems pretty significant when you're riding in that plane or when you're driving on that car down that road. Anyway, going to get some problems like this. Hopefully you guys understand what's going on with this. Just taking some practical examples and using our sine, cosine, and tangent ratios to solve. have a great day. Hope to see you in the Google Meet, and we'll see you another time.